And here we go.
There's the W. Here's ignition.
Roger, roll, Atlantic. Doubling up.
Did it just do a Kerbal?
Back to the moon and beyond.
Put that in the big bag, you know.
At home, we all have a lot of work to do, but from here, that sure looks like a perfect flow.
Propulsion continues to be normal.
We did have an observation.
Equalize.
343 unfolds to go.
It's orange.
Water towers can fly!
Bingo! Right in the center.
Where's Jacqueline? There it is!
That was surreal.
That's not what we want to see.
No!
Oh my god.
Yikes. You bet. Sure. We don't need any more of these.
Good afternoon. You are taking a live look right now at Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida, where SpaceX is finally going back to launching a single-stick Falcon Heavy, or as we like to call it, Falcon 9. I'm Sawyer Rosenstein. I will be your host for this broadcast today, and as always is the case, I am not alone. Joining me today on stream is Alex. How's it going, Alex?
Well, it's going very, very well. I think, it's a very nice way to celebrate. It's been a month since the Artemis 2 launch. How about that?
To the day, and oh my god, it hurts to hear that.
Yeah.
Oh god, time flies. Also joining us today out in the field is D Wise. How's it going, D?
It is going pretty well. We've got a vertical rocket on the pad that is supposed to launch, and it is always a good day when you are looking forward to a launch.
Absolutely. So this, Alex, is the Starlink 10-38 mission. Do you mind filling us in on all the fun facts about this one?
Yeah, I'm sure a lot of people have forgotten since the last time we covered the Starlink, because that was 17 days ago.
Does that make this
boy.
not your ordinary Starlink?
It is not your ordinary Starlink, because it wasn't 2 days ago that another one happened, I guess. But yeah, you can see all of the stats there. A really long list of stats for today's mission. One of the things that I'm really interested, of course, it's the first SpaceX launch of the month, but it's definitely not the first of the year. It's still the 53rd, which is crazy that we've had already 52 launches by SpaceX just this year alone. But yeah, this is going to be the 384th dedicated launch to Starlink. So, of course, if you don't know how this works, it works by launching internet satellites into low Earth orbit. In this case, for this one in particular, they're launching them into a 53-degree inclination orbit. What does that mean? Well, it means that these satellites, their plane of the orbit sort of orbits with an inclination relative to the equator of 53 degrees. And this means it's a very perfect orbit to be able to cover, for example, mid-latitudes. A lot of the people in the world, because of weather and climates and things like that, they all live in mid-latitudes, both north and south. And so, when you put all of these satellites in this kind of 53-degree inclination orbit, you get a lot of them clumped together. Sort of if you were to make a ground track of their positions, you will get them over 53 degrees north or 53 degrees south. And as I said, that's mid-latitudes, north and south. A lot of people live on those areas. So yeah, this is just one of those missions to enhance the coverage of Starlink over those areas. Of course, 29 of those Starlink V2 mini satellites are launching on this mission. As usual, this profile is going to go to the northeast in the case of these 53-degree inclination orbits and the Group 10 missions in general. We're going to have, as you can see there, those two hazard zones. The one a little bit closer to Florida is for launch, and then the other one is for the booster landing because it's landing downrange on a shortfall of Gravitas. We no longer have to wonder whether it's going to be just read the instructions or a shortfall of Gravitas, because just read the instructions is no longer going to be a drone ship in Florida for booster landings at the very least. It'll be used for Starship transports. But yeah, that's very much what we should expect for that first stage flight. Of course, the second stage will do a first burn to insert the satellites into sort of like a preliminary orbit, right? And then about 50 minutes later, it'll ignite the MVAC engine again. That second stage engine will ignite for just a brief second in order to circularize the orbit, and then 10 minutes later, the satellites will separate and they'll start doing their own things to, raise their orbits, checkouts, all the things that you can imagine they do with these satellites before operations. Was that thorough enough?
Yeah, I don't know. It could have gone into more detail. No, that was pretty good. But yeah, it still hurts to hear just read the instructions not being a drone ship for Falcon landings anymore, but that's just me. So yeah, as you talked about, the booster will be landing on a Shortfall of Gravitas. This booster in particular is a very nice booster in the family, B1069-31. So it has quite a long lineage here, including CRS-24, Hotbird 13F, OneWeb 15, SES-18, SES-19, and then all the rest were past Starlink missions. Goodness gracious, that's a lot of them. And yet, Alex, this isn't the oldest one in the fleet, or the one with the most flight heritage in the fleet. This is what, second or third?
Yeah, it's one of the, so in terms of longevity, it's the third oldest, but as we usually say, right, just because it's the third oldest, it doesn't mean that it is the third most flown booster. In this case, it's actually the fourth in that sense, because there's another booster, B1071 from Vandenberg, that sort of, it went ahead. It's mostly due to this booster's first flight being a little bit, it had a bit of an incident, right? If you remember, that was CRS-24 way back when. This was like many years ago. Just for reference, we're coming up on CRS-34 next, like a couple of weeks from now.
Oh.
So that's how long ago it was. So CRS-24, the booster landed fine, but on the way back, there was like really bad weather. Octograbber, I think it was only half connected when the booster was sort of shaking and everything, and sort of the engines got all turned up and everything. The booster survived, like the rest of the booster survived, so they were able to fix the engine section and sort of keep flying it. I mean, this is the 31st flight, right? Like it's still flying, but that meant that first turnaround was way longer than they probably expected at the time. It was in fact nearly 250 days. So now a booster doing that long of a turnaround, it's very rare. So that means the other booster from Vandenberg sort of caught up and yeah, overtook this booster. So yeah, third oldest, but not third most flown. It's the fourth most flown, but still quite an old booster in comparison with the rest of the fleet.
Yeah, you're not kidding. It's kind of weird to say, oh yeah, it's only the fourth most flown when it's on its 31st flight. That is wild to me. But yeah, I forgot to mention earlier, by the way, Daniel is the one who is going to be producing today, pushing buttons, pulling the levers. And as always, if you have questions, you can tag us at NASA Spaceflight or at NSF, and the questions will appear in a panel that we have here in the background that will pull them up for us. So at this point now, we are about 50 minutes to go until launch. And hopefully we will be getting the go for prop load coming up soon in about 10 minutes. And if all goes well, that means that at T-minus 35 minutes, they will start loading up propellant. Of course, they did have one hold already that they pushed this launch by about 30 minutes. Don't know exactly why, but I guess one of the big questions is, could it be weather related? And so, D, what is the weather currently out there at the Cape?
The weather out here is actually quite wonderful. It's blue skies, but there are some clouds in the sky. And looking at the 45th Weather Squadron's forecast for this mission, those clouds are their primary concern. So there is a 20% probability of violation for this afternoon launch window, with the cumulus clouds rule as well as the thick clouds layers rule being those primary concerns. There aren't any real additional risks as far as booster recovery weather or the solar activity, But looking out over Slick 40, there are some clouds in the sky. So depending on how exactly those line up, those could be what SpaceX is keeping an eye on to make sure everything is good as they work closer towards this launch.
Yeah, hopefully clouds don't become an issue as we saw with the first Falcon Heavy attempt earlier in the week. Of course, there's that concern of if you have really thick clouds, especially the cumulus clouds that tend to produce rain and thunderstorms, by sending a rocket right through it, you have something called triboelectrification, which, long and short of it, means rocket creates its own lightning and strikes itself with lightning, which is bad. So that's why they are concerned about what cloud types in particular are overhead when they launch. Let me thank the people here as I see more questions coming in. Grissu with the boop as we are on the air now. Thank you very much for that. Don't Panic becoming a Pad Rat member. Appreciate it. And Ron Smith, shout out to the OG Space Fleet members Liberty Star and Freedom Star. Hashtag I'm old. Oh my gosh, I remember them very well. I was fortunate enough to see SES-135. I think it was Liberty Star come back with one of the boosters into port following the final shuttle launch. And those things were amazing. It's a shame we don't see recovered SRBs anymore. But yes, shout out Liberty Star, Freedom Star.
Fun fact: these two, well, at least one of, I think it was Liberty, might have been that one, or one or the other. I do know that they were used by SpaceX on the early Falcon 9 recovery days when they were still using the parachutes. They were not going to be the ones recovering, but they were fitted with like infrared cameras and things like that in order to spot the boosters coming down. And there's even like some kind of old NASA video about those out there, sort of how they were partnering with SpaceX and everything on how they were getting data out of the booster entries and whatnot. Too bad that those early boosters sort of broke up, and that's why they sort of shed the parachute recovery plans for Falcon 9, and they went with propulsive landings, which are arguably cooler.
I mean, yeah, they're not bad, though I don't know if it'll ever catch on landing boosters back either on land or on a drone ship. That'll never work. Speaking of not working, we have some breaking news that just came in. And there we go. The Kennedy Center Director over at NASA, Janet Petro, will not be working anymore, at least for NASA, as she announced that she is retiring. For those who recognize that name, Janet Petro has been in NASA for quite a while, both at the Kennedy Space Center, NASA headquarters in Washington, really just doing a lot of behind-the-scenes work, including things for space science and all of the management side of things. So if you know NASA, you know that she has played a major role in things, starting with the agency back in 2007, and was also the acting administrator for a while prior to Sean Duffy, prior to the actual administrator, Jared Isaacman. So we wish her the best of luck on her future career. That's pretty cool. Let's see here. Let's get to some questions. This one sounds like an Alex question if I've ever heard one. In fact, I got a couple for you, Alex. But this question from Super Cool Driver is: how many Starlink satellites does SpaceX have?
Oh boy. So yeah, I will have to pull up McDowell's stats for this, because this is one of those things that it really is so much data that I really cannot work on this kind of data myself. But Jonathan McDowell, he really has a lot of these things already put together in a very nice website. I can link to that in chat if you want. But yeah, he's got there some kind of table, if you will, of all of the different types of Starlink satellites that SpaceX has launched, how many of them there are in space right now, how many of them are sort of like decaying, sort of like, they seem to have their orbit not being raised and things like that. And so that kind of gives you an idea that, they're probably not in good shape. So yeah, because a satellite is in orbit doesn't mean that it's all fancy and dandy, right? It's not going to be completely well. So there's like about 16, I think, that are currently not in good shape. Let's put it that way. There's like multiple different classifications that Jonathan also keeps in his table. But yeah, right now, according to his data, there's 10,296 satellites in orbit right now for the Starlink constellation. There have been many more that have been launched, but about 1,581 have been deorbited since then. And so, yeah, that's basically the number.
And a reminder, that's part of the plan. That's part of why they launch into such a low orbit compared to, say the geostationary satellites that deal with internet from there, because it means lower latency, but that also means a slightly shorter lifespan. And also, if one of the satellites breaks or stops working or has a thruster issue, that means regardless, it will eventually encounter enough drag that it will burn up in the atmosphere and it will stop the spread of more space junk.
Yeah, and even they have an orbital, sort of like an operational orbit, right? In this case, for these satellites, they've been lowering them from like 500 and something kilometers to somewhere around 460 kilometers in altitude. But today's launch and many of the other prior launches, they don't launch directly into that orbit. They actually launched to somewhere like 200 kilometers lower. In this case, for this mission in particular, is a 251 by 265 kilometer orbit. So it's sort of like, oval shaped and whatnot, with lowest point 251 kilometers in altitude, the highest point 265 kilometers in altitude. And that means that it's low enough that if one of the satellites fails, then, even without any commands or anything, within a couple of weeks, it re-enters, right? And we saw this sort of problem happening on Starlink 9-3, because to get to this orbit, they actually do like a 2-burn profile, right? I was talking about this earlier. And so what they do is they first go to an orbit where the lowest point is closer to like 130 kilometers or so, which is very, very close to the thickest parts of the atmosphere, right? And then the highest point is in that sort of, 250, 260 something kilometer altitude. And then they sort of wait until the second stage is all the way to that altitude to do that very brief burn that I was talking about earlier when I was overviewing this mission. And then they circularize the orbit and sort of raise that lowest point in the orbit. So what happened on Starlink 9-3 is that, well, that second burn did not work because the second stage was shedding liquid oxygen everywhere, and it cooled down the engine, and it couldn't relight and things like that. And because of that, these satellites were deployed into a really, really low orbit. They came back within like 2 days of the launch happening, right? And so this is one of the benefits of launching so low in the atmosphere, but also, if your rocket doesn't really work that well, then that means the satellites are, not going to be racing up into the highest, the operational orbits.
Yeah, it's all about trying to be good neighbors in space at this point. So we are coming up now on 40 minutes to go until liftoff. We are starting to get towards the exciting part of the count D. What can we expect now as we hopefully get ready for propellant load?
Yeah, so as we approach the T-minus 38-minute mark, that is when the flight director should give go for propellant load. And then just a few minutes later, at T-minus 35 minutes, that's when they'll actually start loading propellant onto the vehicle. And that's a crucial point, because once they start loading in propellant, they are locked into this T0. Up to this point, they can shift around within their launch window as needed, but once they start loading propellant, they are locked in. Now, as we get even closer, we'll be looking for the famous T-minus 20-minute vent, which will be ahead of liquid oxygen loading on the second stage. And then once we get into the last few minutes, events start happening pretty much in rapid succession ahead of that crucial final go for launch and liftoff.
So that's what we will be hoping for. Of course, the big thing is getting, hopefully, that go for prop load. We don't unfortunately get to hear that. So the way that we typically know that they are go for propellant load is once we start to see frost forming on the vehicle. So once we get below 35 minutes, we will all be on frost watch. Here's a question from Saad and Alex. They're wondering which engines on Falcon 9 can gimbal.
All of them. All of the 9 engines on the first stage and the one on the second stage, all of them can gimbal. It's not like, when we talk about Starship, right, where you've got the outer 20 engines on the booster, they cannot gimbal, or the RVAC engines on the ship, they cannot gimbal, or on Blue Origin's New Glenn, for example, on the first stage, only 3 of them can gimbal, the other 4 cannot gimbal, and then on the second stage, all 2 of them can also gimbal whenever it works, right? And so that's one of those things that it's like, well, if you really have all of the 9 Merlin engines being able to gimbal, then why don't they remove a little bit of that gimbal, right? Might be thinking some people out there. And the reason is you really don't need that much of a gimbal authority. Actually, Merlin is like, I think, like a couple of degrees of gimbal authority. The center engine does have a little bit more room because it's mounted lower because of the dome and whatnot. The way that sort of the geometry of the aft end of the booster works, right? But other than that, it's not gimbaling that much. Raptor engines, they do gimbal a lot. We've seen that, right? It's like 15 degrees or something crazy like that. But yeah, Merlin doesn't really need that much. Like the gimbaling system doesn't really add that much mass, I guess, or doesn't really impede the movement or anything like that. Like you can just do all 9. It's fine.
There we go. And of course, all 9 of them steering. And another question that just came in related to that. Dennis is wondering, is there a particular order for the ignition of those 9 Merlins, or are they all just started at once? Now, I know it's staggered, right? It's not all 9 at the same exact time.
It's a little bit like very subtle. But by human standards, it's very much an instant, right? It's like all of them.
Yeah. The
at
naked
once,
eye
but
wouldn't be able to tell.
Yeah, you can sort of see it on the, like, if you go frame by frame on the overlays from SpaceX, right? You can sort of see that there's a little of a stagger, but very minimal. It's even shorter than like, for example, when we saw the Starship's version 1 and 2, right? They used to do like one ring, like the center 13 first, then 15 of the outer 20, and then the remaining 5. And usually the timing was like 1 second in between those ignitions, and so it was very visible. Like you could see it live, right? And we used to see it even as we were preparing for launches when they did the static fires and things like that. We will see it. It was like, yep, you can with your eyes in the moment, you can really notice that staggering. But in the case of Falcon 9, it's very much like, an instant. They do shut down. So in terms of shutting down, it's a little bit more visible. They shut down in pairs, except the last 3, because it's 9 engines. So if you were to do in pairs, you end up with just 1 at the end. So the last pair actually shuts down at the same time as the center engine. And so you can actually see it. If you get really good views from the ground, you can actually see that. That stagger shutdown, it's a little bit more spaced out in time, but yeah.
Let's see here. We got some really good questions coming in today. Appreciate it, everyone, with tagging NSF or NASA Spaceflight. There's a question here from Geek Evation asking, I've been gone for the satellite separation. How do the satellites separate? How does that work? Alex, I believe it's tension rod still.
Yeah, so you can imagine like a stack of cards, right? Like a deck of cards sort of stacked together. And then you have like a rubber band holding them together, right? And then you release the rubber band and sort of they all float around. So they are held very similarly. Instead of rubber bands, of course, they don't use that sort of thing for at least the holding them together. They use tension rods, which is very similar concept. Basically, like 2 U-shaped rods, basically on each side of the stack that are connected to the second stage. And then what happens is that the second stage starts rotating. I think it's like a degree per second or something like that. It's a very slow rotation. It doesn't really take that much. And then they sort of open the rods, right? That those U-shaped rods, and then the satellites get freed from the second stage. And because the second stage was rotating, and because of the moment of inertia, you can think about the figure skater sort of thing, where you stand out your arms and you slow down, and then you bring the arms together and you spin up faster. Sort of same thing, right? In the case of Starlink satellites and the second stage, well, the second stage weighs X amount, right? And the satellites weigh Y amount. And because of that difference in the masses, then they sort of spread out and sort of get pushed out just by inertia, basically. And so that's basically how it works. The rods themselves stay attached to the second stage. They have a system where, if you imagine opening them up, right, they will hinge and swing all the way back against the second stage. So what they have, if you can look at the second stage, it's barely visible from this view, but there's like a patch of Velcro on the tank of the second stage, where those rods sort of end up being glued to, I guess, or Velcroed to. They have like a patch there where they can sort of Velcro to the second stage and minimize the impact to the second stage, and also so that they don't end up, floating around and being sort of, I don't know, fluffy and things like that, right? But yeah, whenever the second stage sort of reorients for the orbit burn, something like that, they are not flapping around or anything like that. Yeah. So that's basically how it works. It used to be that those rods will just separate and become space junk. No more.
Yay, less space junk.
Yeah.
I mean, that was a problem for a while. They were trying to come up with missions to clean up all the old space junk, to either bring satellites back, refuel to refurbish them, or find a way to get them deorbited. That was the big thing I remember of the late aughts and early 2010s, was how can we get rid of all this space junk? And I know they're still working on that, but now, of course, the big thing is just don't create any in the first place. Just be able to get rid of everything you make.
Exactly.
All right. Let's see what we got here. Related to that, I saw one Air RN asking, what happened to those Starlink trains?
Well, they still exist. I know of people that still see them, but one of the bigger changes that happened, especially with version 2, is that the satellites are coated in a very special sort of, it's a paint. It's more like a material, right? But that material sort of prevents most of these reflections that used to cause the people on the ground to be able to see the Starlink trains. You can still see them. There's also many fewer satellites at a time. We're talking 29 satellites today. Most of all the other launches from the Cape are also like 28, 29. From Vandenberg, they also tend to be anywhere between 21, 22 to 25 as well. So it's not a lot, whereas in the past it used to be like anywhere between 50 and 60. The early missions were in fact like 60 at a time, right? I would suspect that we may see the return of some of those if they start launching them on Starship, because Starship will be carrying 60 of them at a time, and so there's going to be a higher chance that you're going to see a good chunk of those, right? But yeah, they have mitigated the visibility of these satellites quite a lot in the last few years, and so nowadays, like, you will need a very dark sky to be able to observe this. Also, being able to know exactly where to look at, because the dimmer that these satellites become, then the more you have to actually look for them, rather than suddenly you look at the sky and it's like, oh, there's a Starlink train,
So
like it used to be at the time.
one of the really cool sort of counterintuitive things that I've loved learning about the Starlink satellites is it's not just like a dark paint, but they're also making use of almost mirror surfaces
Mhm.
that are extra reflective, which seems super counterintuitive.
Yeah.
But because it's a mirror, more so, they can control exactly where the light reflects to. It's not just scattered everywhere, so anyone on the ground would be able to see them at the twilight
Mhm.
time. they're able to control where the light goes, and it's a much smaller area that would see those what would most likely be like brief flashes rather than just a glowing dot crossing the sky. And so it's so counterintuitive that they
Yeah,
would go to mirrors for some of the surfaces, and they've done like huge white papers on it. But I just find that really
yeah.
cool.
Yeah, you're right. They have on their website, I don't know if people might be aware of this, that they have a specific section on their Starlink website for this kind of thing of like technology in the Starlink satellites to prevent and mitigate all of these impacts to astronomy and things like that. And so they have one part where it's like the underside of the satellite, they have like different parts that are actually polished and mirror finished because they are meant to point sideways. Like what you do is you've got the light hitting in such a way that eventually the reflection actually goes out sideways. And by doing that, they're not going down. Like that reflection doesn't go down to the ground, doesn't go down to earth, right? That's what you want to avoid. And so that's one of the things that we're sort of explaining in some of these updates and sort of the way that they sort of go through that. And I think that's really ingenious that they were like, yeah, duh, you want the reflection, if there are reflections, you want them to be pointed away from the earth, right? Or at least as parallel to the surface as possible so that if they reflect any light, sort of reflects out into space.
It really is amazing how they've upgraded it from this is, a monstrosity to astrophotography and astronomy to, oh, we'll make it darker to, yeah, we'll just reflect. I
Yeah.
mean, hey, it works as long as it works, right? Uh, let's continue on with your questions here. Um, Resistor Jet's wondering, how do they keep track of more than 10,000 satellites?
Ooh, they actually posted another update about this. In fact, they have a very special software to be able to work with that. Uh, we could probably talk about this for a lot longer, but in essence, they have a lot of control algorithms and basically using tools like AI to be able to help themselves with this sort of thing. It's a lot of satellites, a lot of data that they have to track. So yeah, as you can imagine, a lot of things need to be automated because of that.
Here's a really interesting question, and D, I want your opinion on this. Resistor Jet also asking, depending on how soon Starship manages to successfully launch Starlink V3s, will that mean the beginning of the end of Starlink V2 and phasing them out, and then Falcon 9 not needed for Starlinks at all anymore?
Ooh. Well, I think at all is a bit strong because I think as soon as Starship starts to launch Starlink missions, the vast majority of missions will be focused on Starship because of that huge added capability. But I think we should also consider the Star Shield variants and the sort of DoD purposes, and some of that will probably stick with Falcon 9, I would expect, but I think as soon as Starship starts launching Starlinks, we will see, and we're already starting to see some of that decrease in cadence, at least from the Space Coast of Starlink missions. It's been a while, and it's sort of slowing down just a bit. So I think Starship will get a big ramp up as Falcon 9 ramps down, but not necessarily entirely.
Yeah, I mean the fact that it's been what 17 days since we've seen a launch from Slick 40, which has been the busiest launch pad in the world for a while now. It's kind of strange to see how much it's already starting to back down on it. And even so, we're talking, I think the most recent one was the GPS 3 mission, not even Starlink. So it's kind of wild to me how that's changing. Um, Continuing on with questions here. Here's an interesting one from 98 Central. We were talking about originally, there's always the concerns of the cumulus cloud rule and the different types of clouds that it would have to fly through. 98 Central is wondering, does the cumulus cloud rule also apply to the drone ships downrange? Ooh, I don't know if I know the answer to that one. Do you, Alex?
It shouldn't, for the whole thing that this is for launch. So when we talk about the Cumulus Cloud rules and all of these different rules, these are rules from the 45th Space Wing, the Space Launch Delta 45 now, right? SpaceX may have some kind of own rules, right? But we don't really know about those because it's sort of proprietary. It's sort of their thing, right? But it's not something that you should expect in terms of like there's X rule from the range or something like that. At the end of the day, all of that happens downrange, right? No pun intended. But but it sort of happens away from their territory, right? It doesn't really concern them. It is true that they do include like in their additional risk criteria box sort of that booster recovery weather part as well. But that's sort of like to give you a little bit of a extra information, right? Because they also help SpaceX with this forecast downrange. So, for example, for booster ascent, when they do a crew mission, they also help with that sort of thing, right? They're weather people at the end of the day. So if you give them the data, right, and they have the assets for that sort of thing, they're gonna help you out, and that's one of the services that they also do. They also help. If we want to switch to this very briefly, they also helped, or at least until now, they used to help on Starship launches. Because whenever Starship launched, up until Flight 11, these missions sort of went between Cuba and Florida. And when it passes through that, they pass through the Eastern Range. And so now, on Flight 12, that's no longer be the case. Because you can see there, they're going to be having a new trajectory. We had today new hazard zones for Flight 12, indicating that it may happen maybe in 11 days, no earlier than May 12. Probably going to be a little bit later if I'm going to be honest, my own personal opinion here. But one thing definitely that it's coming new is that new launch trajectory between Cuba and the Yucatan. So definitely much different than what we have seen so far.
Oh, yeah. I'm a little bit annoyed at that because we've been able to see some of these Starship launches from the Space Coast area and from South Florida during the launches. Especially, I think it was Flight 11 was able to see it. And of course, some of the other anomalous launches, the non-normal ones, were able to see it as well. But I don't think we'll be able to see it anymore, which is a bit of a shame. And of course, we'll be talking a lot more about that in just a little bit on the Flame Trench. That is our weekly kind of lighthearted news show where we go over everything happening in spaceflight that we find interesting and talk about it with you. So make sure you tune in for that at around 5 p.m. Eastern today. So that is still to come. Also still to come here in approximately 10 seconds or so is what we like to call the best vent. So let's give it a couple seconds here, and we will know that they are on time for launch if we see said vent.
Maybe there? Oh, it's going through the tower.
Yep, you can see it through the tower right by that kind of little branch there. But that is the 20-minute, 20-second vent, which means they are indeed fueling and they are indeed committed to their current D0. That also means that RP1 load is complete on stage 2. So now they are going to thermally condition that line and prepare it for liquid oxygen load. The LOX is a super chilled propellant. It is very, very cold. The RP1, while cold, is nowhere near as cold. It's more closer to ambient temperature than it is to super freezing. So they need to prepare the lines for the colder oxidizer to load on in. Meanwhile, stage 1, RP1, and LOX load both continuing at this point. And once that vent goes away, well, that should mean that they have started LOX load on stage 2. Now, I noticed it's kind of lingering around the rocket there, D. I mean, what is the wind looking like and the humidity out there? Because that vent says a lot about the weather.
Yeah, I mean, there actually is a slight breeze occasionally, but it's not by any means a consistent breeze, and it's kind of changing direction. I think it's pretty humid right now. I don't recall the exact humidity, but I mean, it's always humid in Florida. It's okay, 65% is what it is right now, so that's actually not all that bad. But yeah, there's not a heavy breeze in any one direction to carry the vent away from the rocket.
We'll see what that ends up meaning for sound as well, based off the direction of that wind. So hopefully we get a nice rumble today and a good old VAB squeal. You can see that flag flapping a little bit. There's some of that breeze that D just talking about there. Let me take a moment. Thanks some people here. Bideford with a $25 super chat. Good to see you, Bideford. Saying, what would I do if we don't have at least 2 launches a week? More better. I mean, we technically have been having more launches, just a whole bunch of different rockets, not all Falcon 9, which has actually been really nice. Although it may still be a while before we see Vulcan return. It may still be a while before we see New Glenn return. So it'll be a while before we see Falcon Heavy return. So it might go back to, Atlas and Falcon again for a bit, but we'll see. Benu Berry asking Starship question. Flight 12, May 12, is that even possible? They're trying the 33 engine fire next week, right? And also they would have to bring it down and roll back, then roll back again for wet dress. I mean, I'm sure we'll go into more depth on this afternoon, but Alex, what are your thoughts on that?
I think it's gonna be at least another week beyond May 12th. I think these hazard zones that we have seen published are probably coming from like maybe filling for them maybe a week or two ago, right? I think it's still gonna be another week or so until we see Booster 19 coming out and getting ready for flight. And then I have no idea if there's gonna be another if there's gonna be another 33 engine static fire test. There may be another one. I'm not sure if there's such a static fire that they will need to roll it back. In theory, there shouldn't be, right? Like they could roll out Booster 19 already flight ready, like already with all of the closeouts and things like that, and just needing to fire the engines and go. But then there's also Ship 39 that needs to go out. They need to do full stack testing as well. We don't know how many full stack tests they might want to do, right? Like maybe a partial propellant load test and a full, right, with a full wet dress rehearsal and whatnot. So we'll see. We'll see what's going to happen. I think it's more like second half of May when this thing is going to launch. But it's a good thing that we at least have an idea more or less where they want to be launching this and where this might go in the calendar.
Yeah, I mean, it's good to at least have a sort of timeline to go off of. So now we can say when Flight 12 on the 12th.
Yeah, I also want a little bit more time, please, SpaceX, because we really need the time for assets and yeah. We're starting to prepare all that.
Yeah, we have a lot of pre-launch work that we at NSF need to do beforehand, so we appreciate the extra time. Thank you. Also, that's supposed to happen as of now, the right around the same time as the next resupply mission at the ISS. In fact, the same day. In fact, during the same window, the CRS-34 ISS resupply mission is also May 12th. So yeah,
15 minutes later, there's a Starshield launch from Vandenberg as well. The same day, there could be 3 launches by SpaceX. I can already tell you these launches are going to be moving around. They may delay a bit.
I would think that the ISS one takes priority because it has an instantaneous window, and also it's a contracted mission with NASA, not one of their own. So that would just be my guess, is that if any of the 3 were to stay put, it would be the ISS mission. And in fact, they just updated their whole ISS launch schedule a couple, what was that, about less than an hour ago they made the announcement. So we still have that for May 12th. The next crew launch from Baikonur is July 14th, which I just did an interview with the NASA astronaut that will be flying on that mission, Anil Menon. So if you haven't already, you should go check that out on nasaspaceflight.com. He was amazing to talk to. And then Crew 13 moving up from November to mid-September. And then sometime in the fall, we would have CRS-35, and then either fall or winter would be NG-25. That's the Northrop Grumman Cygnus vehicle. So yeah, lots of things happening. That's for sure. Let's see here. JPS asking, and I'll throw this one to you, D. how close would I have to be inland to see the launch? I'm guessing they would mean inland somewhere in Florida, or do they? Yeah, what do you think?
Yeah, I mean, you can be a shockingly far distance and see the launches, but it depends on luck and lighting. I would say if you're anywhere within 20 miles, you're pretty likely to see it. But of course, the closer the view, the more likely you are to really see the details. So if you're anywhere in the Titusville area, the Port St. John area, Cocoa, uh, and expanded off from there, I think you have you're quite likely to get a great view for today's launch here in just about 13 minutes. So I would not stress out about it too much if you're just now looking for a spot. I have seen launches from as far away as Orlando, and I believe some people actually not just Orlando. I was down in the Everglades for one launch that happened to have a good trajectory to line up with visibility. So it is always worth a shot to try to see this launch and any launch that you can. We even have a video if you do want to get the best possible view of how to watch a rocket launch in Florida. And we go over all the different locations that you can go and take a look at. So I'd highly recommend giving that a watch if you have a chance. But anytime you see a launch, just step outside, look in the general direction of Cape Canaveral and see if you get a view. And if you do, let us know. Tag us on social media. We love seeing it when people get their own views of these launches.
Exactly. Yeah, and I see a lot of people in chat who are over on the west coast of Florida, Tampa area, Ocala, Pinellas County, all saying that they are able to see it. And this one, again, going towards the northeast, if I remember rightly on this one. So there's a chance along the coastline you might be able to see it. I will say it is a lot harder to see these during the day than it is for a night launch. Obviously, you're basically looking for a smoke trail, if anything. You won't be able to see the orange glow of the engine as clearly the farther away you get from the actual launch site itself. So, never hurts to go outside and take a look if you're anywhere along the eastern seaboard for this one. Continuing on here, um, T. Siren asking Alex, has SpaceX started to replace end of life satellites, or how long do these satellites actually last?
Yeah, in fact, some of these V2 mini satellites are replacing a bunch of the old V1 satellites and V1.5 satellites, especially the ones that didn't have the inter-satellite laser links, the old V1s. And so, yeah, a bunch of these, like this particular orbit that they are targeting, for example, is one that you will see back in the day with those old satellites. It's basically probably one of these replacements. We don't know exactly which one might be replacement and which mission might be more of a extension of the constellation, because it's all mixed together. But at the end of the day, you can think of maybe some of these satellites will be replacements, some of them might be expansions, but yeah, could be a mix. Tolkien, well muted. Am I right?
Yes, you're exactly right. Yeah. Always a great start. Anyway, under 10 minutes to go now until launch. Fathom's Enterprise was saying, I missed the Falcon Heavy. Did that mission look cool? Yes. Yes, it absolutely did look cool. It was beautiful. You can go back and rewatch the live stream here on NSF YouTube channel, or you can grab some of the merch over at shop.nasaspaceflight.com, all from our Falcon Heavy collection. I mean, it's an oldie but a greatie. It's awesome to finally get to be able to bring this out again after a year and a half of no Falcon Heavy launches. We have all of our heavy gear, which I was wearing all of mine for that launch, both Falcon Heavy in gray, in black, and then the launch entry landing shirts for all 3 days I was up there. That one, in fact. So if you want to show your love for Falcon 9 and Falcon Heavy, since it's finally back again, you can check it out, shop.nasaspaceflight.com. So now, as we're under 9 minutes, Alex, do you mind just giving us kind of a recap of this mission and what we are expecting, where it's going, etc.?
Yeah, we are having 29 Starlink V2 mini satellites launching into low Earth orbit. And for this mission, we're going to see 2 burns of the second stage once it goes into orbit. Of course, the first one will be putting the satellites into the preliminary low Earth orbit, and then the second one will sort of circularize the orbit, and then the satellites will be released. Now, in the case of the first stage, we've talked about this. It's a very old one, B1069. It is flying for a 31st time on this mission and will be landing downrange on a shortfall of Gravitas. The fairings are also flight proven as well. We don't know exactly how many flights, but we know that they are flight proven, and they're also going to be recovered downrange by Bob, one of the fairing recovery vessels out there. We should be under a minute now from engine chill on the first stage engines.
Hi, Bob. And as we are getting towards that engine chill, D, I know you're going to have to get ready to go all hands on with your cameras, but before we do, can we get a final weather check from you?
Absolutely. It is blue skies, and directly over the launch pad, it is clear. If I look behind me and I look around too much, there are some clouds, but we've got a very light, nice breeze, blue skies over the launch pad, and I think it is a good day and good weather for a launch.
Absolutely. So we are going to let you do everything you need to do ahead of launch, and we will check in with you after.
All right. See you on the other side.
So now, as mentioned, we are coming up on 7 minutes to go, which is when they begin chilling down those 9 Merlin 1D engines, thermally conditioning them for what they are about to experience with these super chill propellants and the super hot fire that will eventually be coming out of it. So all of that set to come. That is why they prepare those engines for that thermal conditioning. Now, this booster that we're seeing today, that is currently chilling down those engines, is B1069 on its 31st flight. This booster has quite a long flight heritage here, although as we were discussing earlier, it is only the 3rd oldest and the 4th most flown in the fleet at 31 launches, which is a bit mind-boggling. But this has previously launched CRS-24, of which, as we just mentioned, CRS-34 is scheduled for later this month. So it's been around a while. CRS-24, Hotbird 13F, OneWeb 15, SES-18 and 19, and then a whole bunch of those other Starlink missions that you see on your screen, going back to the Group 4 days and Group 5. So it is a well-seasoned booster, ready to land on SpaceX's now only Falcon drone ship on the East Coast, a shortfall of Gravitas, with just read the instructions, now being outfitted for Starship transport to and from the Cape here. So coming up on 5.5 minutes to go. Alex, what is the timeline now for wrapping up propellant load on this?
Yeah, so RP1 load should have been already wrapped up about a minute or so on the first stage. So all the kerosene that needed to be loaded on Falcon 9 should be already on Falcon 9. And so the final few things are going to be the liquid oxygen side of things. Before all of those things happen, like before they wrap up the liquid oxygen load, we should have, in about less than a minute now, that Stromac retracting away from the rocket about 1.8 degrees. And so at T-minus 3 minutes, then we'll have stage 1 liquid oxygen load complete. And then at T-minus 2 minutes, stage 2 LOX load complete. And that is when all of the propellant will be finally inside the rocket tanks. Now, about a minute after that, at T-minus 1 minute, Falcon 9 will enter startup. That is when the Falcon 9 onboard computers take over control of the count, because up until T-minus 1 minute, it's all on the ground computers, and sort of they do a little handoff of the duties and control of the countdown, and then that is when Falcon 9 takes over. 15 seconds later, we should have also the go for launch from the launch reactor, and so that'll be hopefully right on time for a liftoff at, if I'm not mistaken, that should be 2:06 and 10 seconds p.m. Eastern time. Hey,
look at that.
That's
There's
a
a
Falcon
booster.
Heavy side booster.
Yes, that is LZ-40 over on the left side of your screen there, SpaceX's newest landing zone, and that is the most recently returned booster from Falcon Heavy, B1075, just based on the soot pattern, if I can tell. There we go. And of course, on the middle of your screen there, B1069 with those fairing halves, with those 29 Starlink V2 mini satellites inside. And now you can see that strong back retracting, in addition to apparently reliable coverage. But yes, that will lean back about 1.8 degrees before throwing all the way back at liftoff to get out of the way of the launching vehicle. Now about
Yeah, that was
3
cool.
minutes to go.
Being able to see still one of those side boosters, B1075, out there, that was cool.
It's one of those you wonder, is like, wait, isn't it going to get knocked over from this launch? But that's not something they have to worry about.
Yeah, it's very nice.
Yeah, because you can see it's also a great way to show how close the two launch and landing zones are to each other there. Typically, if it's a single stick RTLS, then that will go back to LZ40. This was the exception because they had two boosters that they were allowed to use LZ2 for just Falcon Heavy.
Yeah. I'm looking at it and it looks like they were sort of preparing for its lift, but they never got to that point. They have the booster lifter and things like that for the side boosters. Really interesting.
Yeah. Well, they kind of had another launch in the way, and that's the one you see on your screen right now, set to lift off 2 minutes and 20 seconds from now. Should be very close to a fully fueled Falcon 9 at this point, just about there. And then once that happens, we will have a final closeout of all the gas lines out at the pad, which is basically just one big giant puff that you'll see as they purge all the remaining lines of any remaining propellants or oxidizers or anything that is still left, as a way to kind of just prevent anything from accidentally catching fire as the rocket goes by. You don't want any residual gases and things hanging around, and anything super flammable if you don't have to. And that should be coming up in about 10 seconds from now. Again, you may see if we ever see the SpaceX feed, their clock is a little bit behind. That's because the latency. Ours should be real time here. So 90 seconds to go. As Alex was just mentioning, next up will be Falcon 9 entering startup. And that's the onboard computers then taking control of the count. That is also when they pressurize all of the tanks on board to their flight levels. So we should be hopefully having that come up shortly. And then once Falcon 9 is in startup and those onboard computers have control, which should be right about now, the next thing will be a call from the launch director that they are hopefully go for launch. And we do have confirmation that Falcon 9 is in startup. You can see all the frost around the vehicle there and the venting and those vapors, totally normal. And we are go for launch. About 35 seconds to go now until liftoff. We will, of course, stop talking once it does launch and let you enjoy the sound. Just keep in mind, it does take the sound a little bit of time to get to our microphones here at the Launch Complex 39 press site. It takes a little bit for the sound to travel over from Slick 40 at the Cape Canaveral Space Force Station. 15 seconds to go. At about T-minus 7 seconds, that is when the Rainbirds will start. That's a water deluge system onto the pad. And then in a couple seconds, there will be the ignition of those 9 Merlin 1D engines. And liftoff of Falcon 9 on the Starlink 10-38 mission. Go Starlink V2 minis. Go. 75 seconds into flight, Falcon 9 passing the speed of sound and going through max Q, maximum aerodynamic forces, pushing against the vehicle as it goes uphill. And you can see with that sort of trail off there, that means they've passed that point, and we will also now start to see that plume expand as it gets into the thinner parts of the atmosphere, being able to more clearly see those 9 Merlin 1D engines powering Falcon 9 into space. So far, everything looking really good. Got a little bit of a vapor cone there on the way up. And now they are chilling down the Merlin vacuum engine. That is the second stage engine, just as they did for those 9 main engines that you see there. 2 minutes, 5 seconds into flight. Coming up next will be a few events in rapid succession, starting with MECO, main engine cutoff, when those 9 engines will shut down. That will be followed by first and second stage separation. And then following that, we should have ignition of that single upper stage engine, the Merlin vacuum. So we should be seeing that any moment now. And there we go. That looks like MECO. Next up will be that separation. And that looks like a good ignition on stage 2. So now Falcon 9 will continue launching those 29 satellites into space. Meanwhile, the booster is going to continue on its current trajectory with the goal of landing on the drone ship, a Shortfall of Gravitas, located to the northeast. Next up will also be the separation of those 2 payload fairing halves. That's the protective covers at the top of the rocket. Once those separate away, they will re-enter as well, and they have small thrusters and parachute on it that will help be able to steer it to a splashdown area where the recovery ship Bob will be able to scoop them up out of the water and bring them back. And there they go.
Sorry, I had to do that.
No, go for it. You gotta add the fun sound effects.
Exactly. Really
There we
great
go.
views there.
Absolutely gorgeous views today. Helps having those nice, mostly clear skies. And again, the grid fins have deployed on stage 1. That's those kind of interlaced waffle-like structures that you see on Falcon 9 on the left side of your screen. They don't do much now. They're more used in the thicker parts of the atmosphere to help steer the vehicle. For now, you'll see a lot of those little puffs coming out of the booster. Those are the cold gas jet thrusters that are used to kind of help orient it as it's in the thinner parts of the atmosphere / space. And then, obviously, once you get more air going against it, that's when those grid fins will become more useful. At this point, stage 2, still looking good, approaching almost 10,000 kilometers an hour, 130 kilometers in altitude. And meanwhile, stage 1 nearing the highest point in its trajectory, or apogee, as that's called here on Earth. So you'll notice that the speed is going to stop, and then it will speed up again.
There it goes.
And then the number will start decreasing in altitude, and there we go. So it is now on its way back down. But of course, Alex, there's not just going to keep going down and then hope it lands. There's a couple of other things that'll have to happen first.
Yeah, it'll perform its entry burn. That's when, it reaches, tends to be around 60 kilometers in altitude, more or less. It starts hitting the thickest parts of the atmosphere instead of, just taking the brunt force of that aerodynamic pressure against the vehicle. It just ignites 3 engines in a 1-3-1 fashion. So first the center engine, and then it lights up 2 of the outer engines, and those 3 engines keep igniting by for about 20-25 seconds or so. And then when it shuts down, it's sort of the opposite way, right? They shut down the 2 outer engines, and then the center engine shuts down. That burn, it's sort of what we call fighting fire with fire, where it sort of pushes out the air out of the way and sort of protects the base of the rocket from the forces of reentry. It also slows the booster enough that it doesn't see as many sort of high reentry forces as it would otherwise, right? Sort of that helps being able to reduce the impact of reentry on the booster. But yeah, and then of course, much closer to the drone ship, it'll be the landing burn with just that single engine. One thing that I really like a lot is when the entry burn shuts down, the grid fins that you were talking about before start wiggling and sort of positioning the booster for that entry. There we go. Overlay just now changed, and one engine.
The video is, of course, on a couple
3
second delay
engines.
from the graphics. There you
Yep,
go.
and now you can see it on the video. 1 engine and 3 engines. There you go.
Yeah, once you see that sort of rectangular shape, that's when you know that the 3 of them are burning, because they do burn in a line if you were to look right at the base of Falcon 9. In fact, you can see it on that graphic there, that kind of diagonalish line.
Yep.
And then back down to 1, and then none. And there it is on
There you go.
screen, 1, then none.
And now firing those jets. And you can see the angle with the atmosphere there, the horizon, how that inclination, that sort of slope, it's crazy the way that they fly these boosters through the atmosphere.
And again, this booster on its 31st flight at this point. So this is one of the older ones in the fleet, B-1069.
It's going to go through the clouds as well, which is always cool.
Yes, once it pops through the clouds, hopefully we'll be able to see the light, or at least the outline of the drone ship, a Shortfall of Gravitas. And then once it gets closer, that is
Look
when
at the
we will see
layers.
that- Oh my gosh.
You can see the layers of the clouds in the atmosphere. Wow.
And that's when hopefully we will see that single engine burn on that center engine to slow it down, see the landing legs deploy, and then hopefully touch down safely on the drone ship. Now, 8 kilometers in altitude, all the way down now to under 1,300 kilometers an hour. Still pretty fast when you think about it.
Yeah, just went transonic.
Now you can see the kind of shake as it actually encounters thicker atmosphere.
Look at the grid fin.
Oh my goodness.
Wow.
The airflow through it. And we'll start to see those grid fins moving in just a little bit as we have... There they go. And that center engine ignition. Next up will be the landing leg deploy. And then hopefully a successful touchdown. There is the deck of the drone ship. You see it on the right. You can see it starting to come into view on the left. Landing leg is deployed, and touchdown. A beautiful landing for B-1069, now -32, and a Shortfall of Gravitas, the sole East Coast landing drone ship for Falcon now. Finally seeing some action again. And now for stage 2 here. This will burn for a couple more seconds here before shutting down. And there it is. There's MVAC shutdown, or SES-1 SECO-1, second engine cutoff 1. There is another burn that happens about 50-ish minutes in flight, but SpaceX chooses not to show that anymore to us. But we'll, of course, if we hear any confirmation of it, keep you all up to date on the socials. Now, we do have replays coming, so stick around, because there's still more to come, folks. We'll still get to show you everything, including our DWise slow motion recap at the end. So lots of cool stuff still happening here. Amazing. That still doesn't get old. It's cool. It's just, it feels so weird, Alex, at this point, having not seen a Starlink mission in so long from the Cape.
Yeah, 17 days. Oh,
Was that
yeah,
for all Falcon
it's
9s, or was that just Starlink? Because I know we had GPS-3
yes,
in there.
yeah, Starlink. Let me take a look. That was Starlink 1024, April 14th. And if I'm not mistaken, that should be 17 days.
Wow.
Yeah.
I trust your math. I don't trust mine. I trust yours.
Yeah. 14th to the 30th, that's 16 plus 1 day, that's 17. There you go.
Yeah, and then in between there was the GPS-3 SV-10, which was the final just read the instructions landing.
Yep. It's been a while since we've had a landing on a Shortfall of Gravitas, though. That was on the 2nd of April, so 29 days.
That also marking, according to the sign that they have outside the Kennedy Space Center Visitor Complex, the 32nd launch this year from Florida.
Ooh, let me
Not
take
too
a look.
bad.
Hang on.
That's what their sign said 31 last I checked, and now it's
All
32.
right, yeah,
So
it is 32. They're keeping good track.
yeah. DeAndre Collins becoming with a super chat there, the $2. Thank you very much for that. We appreciate all the support. That's how we're able to have our own cameras out there and bring all these live views to you. And you'll see how many different cameras we have out there for all these launches in just a moment as we work on finishing pulling those replays and getting those on screen for you. But yeah, and it's amazing how fast it was to get to this point, and yet it still seems so slow in terms of upcoming launches. I mean, do we know when the next launch is supposed to be from Slick 40, Alex?
Yeah, that's going to be in about 11 days. That's going to be with the CRS-34 mission. And it's going to be another RTLS. It's going to be another return to launch site landing on landing zone 40. So hopefully they get B-1075 out of the way so that they can land that booster.
I would hope so. But it's amazing how few Starlinks we're seeing now from the Cape. Of course, they still have a bunch out at Vandenberg Space Force Base on the West Coast. But it's weird.
Yeah, between those two launches, so between this launch that just has happened and then the one that I just talked about, the CRS-34 launch, they have scheduled 4 Vandenberg launches, which, yeah, they're. I don't want to say this, Sawyer, but you're getting launch mogged here because it's not. That's not great. You got to launch more often out of the East Coast.
Do I get to say the line, the controversial line?
No, you do not.
I can't say West Coast, Best Coast?
No, you cannot. You're not allowed. Sorry.
Okay, if I'm not allowed to say West Coast, Best Coast, then I won't say it.
Touche. I mean, it's different. How about that? But man, that's. Anyway, my brain's still trying to wrap around that. I'm sorry. J. Floyd with a $10 super chat asking, what are the two numbers after Starlink mean? The 10-38. So, Alex, what was this 10-38? What does that all mean?
Yeah, the first number refers to the group, right? The sort of group of missions, right? That's basically what it means. There have been so far 17 different groups, although they have not launched any, I think, group 12 or group of group 14s or 16s have not existed in terms of missions. But if you were to sort of draw it in a table or something like that, which I do, by the way, on my own spreadsheet, you will see that there's like different kinds of missions, and they are all grouped in these groups. And so group 10 is just this kind of mission where they launch the V2 mini satellites to a 53-degree inclination orbit from Florida. So, for example, there was a point in time where they were doing also V2 mini satellite launches to 53-degree inclination, just like this one, but from Vandenberg. So those were group 11 instead of group 10. And the ones that are launched right now from Vandenberg are group 17. In that case, for example, they are going to sun-synchronous orbits. And, there's multiple different, again, I'm not going through all of the groups, but just to give you an example of, some of the ones that have launched recently. And the other number is just the mission number, so to speak, within that group. It never relates to how many flights there's been of that group. In this case, there's been already 48 with this launch. But, of course, this is not the, dash 48 mission. It's dash 38. It's a weird way that they have to number their missions, but that's basically how it works.
Yeah, I mean, with NASA and the space shuttle, it was always the mission would get a designation, and then no matter where it ended up, because sometimes they would get delayed, or the payload wouldn't be ready or whatever, and so they would move missions around, but it would always keep that same number, which is why most of them weren't in order. But we are able to show you in order some of the launch replays that we have from today's Starlink 10-38 mission. This, the view from Port Canaveral. In fact, Rusty's at the port, which is where we have our fleet cams. It's also a great place to grab a bite to eat and to watch boosters and things as they come back and work on offloading them. So, it's a little bit harder to see in the day, but there it is right by the crane there. If you look dead center, that little white dot that's moving right through the crane, there is Falcon 9. Again, sometimes, as great as these day launches are for when you're up close to it, they can be a lot harder to see when you're trying to look at them from a little bit farther away. So it's that whole debate of, Night launches are harder to photograph and sometimes video, but also easier to see with the naked eye. And in this case, it's kind of vice versa. It can be harder against the bright sky to see the booster as it flies, but the photography is much easier.
You know, Sawyer, I saw someone in chat saying they saw it fly over from Connecticut with a thermal camera, which that's just so cool. So I would love to know if anyone else got a view of it. Where were you watching from?
Wow, and I hope you got some video or something of that with the thermal cam. I'd be really interested to see what that looks like, especially all the way up in Connecticut.
It was Panzerman saying not as impressive as a night launch, more of an oblong white dot, which I mean makes sense. You're really far away. The rocket's so far downrange at that point. But that's really cool.
Extremely cool. And again, these from the robotic cameras that we have located at the Launch Complex 39 press site. Our Robo Army doing their job here. It's a little hard to see 40 because there is a large bush and tree line right from where all the cameras are, so you don't always get to see it super easy on the pad, but you certainly see it once it clears those trees.
And you know, the trees have been constantly growing. I hope at some point they get knocked back a little bit so we have a clearer view to all of 40.
Exactly. Yeah, no, that would be nice. I mean, they did it. I think the last time they did it, I remember was like 2014. So it's been a while. And check this out. Someone using one of the cameras and doing a track on it as well. So yeah, again, this is not someone at the Cape actually doing this. This is somebody remotely controlling this camera here. This robotic camera to grab this shot. That's pretty cool. And that was Gage that was doing that. And then there was a little bit of that vapor cone there.
And the clouds get in the way.
Of course, yeah, you don't get to see the cool part where it makes the little smoke ring behind it. But even though it's not smoke, it looks like for a smoker, it's a smoke. Anyway.
On the other side, it sort of kind of gives you an idea of how fast this thing is going.
Yeah, and
'Cause if it
also
was-
as much as it looks like it's going straight up, you could see it again starting to
Yeah.
do that arc over, especially when you compare it to the clouds behind it.
Yeah. Because if it were just like this, right, where it's all white sky, it's like you don't really have a sense of how fast this thing is actually moving.
Yeah, spoiler alert, it's very, very fast. Yeah, it's a little trickier sometimes when they're going away from you. Southeast seems to be a little bit easier to track, but this one, of course, went northeast. So it's really going farther away from the camera.
Mm.
Wow, Gage tracking this one for quite a while. I guess it helps having the clearer skies, too.
Yeah.
I think this one was a really nice balance of you don't always want clouds in the sky, but sometimes they create a nice contrast. And when the rocket passes behind them and you get the detail in the exhaust, they can make a much more interesting picture than just a plain blue background sometimes.
Oh yeah, exactly. It's a sort of nature's ND filter for those who do photography. And then this the wider view of the launch from the press site there.
Whee! There you go.
And then even wider view. I love the
I
bird
wonder
there,
if you
great actor.
it worked out perfectly with the track. You'll see it in the slow-mo, which will be the play out. But I like that I was able to capture it there too, because I mean that bird perfectly lined up with it during launch. I cannot complain in the slightest. I watched the bird approach my monitor while tracking, and I was just smiling, knowing, oh, that's gonna be cool.
Yep, there we go. The NSF drones, aka the birds, getting right into the shot. Joking, of course, on that. And Fluffy coming in with the super chat saying DY's favorite NSF photographer for obvious WCBC reasons. I mean, D is a fantastic photographer anyway, but I don't know if that's the reason why. Which, D, thank you for rolling out and providing all the live views for us and the commentary.
Of course, it's an absolute pleasure. It was a wonderful launch. I look forward to seeing y'all again next time.
And also joining me on commentary was Alex today. Thank you, Alex.
Yeah, it's gonna be probably a little bit until the next one, right? We were talking about this today, that the next launch shouldn't be at least until that CRS-34 launch, no earlier than May 12. So it's gonna be a little bit of waiting. But yeah, it's always been a pleasure to be here.
But we still have plenty happening here at NSF between then, especially with
course.
everything happening over at Starbase. And of course, you can watch everything happening right here in the Space Coast with Space Coast Live 24/7. So if you're not subscribed, you should totally do that now. And of course, we have the Flame Trench coming up in just a little bit at 5 p.m. Eastern. So that is, what's that, 2.5 hours from now? And then, of course, This Week in Spacelight will follow that with all of the news you need to know in a more serious format. So lots still happening here. I have to also thank Daniel, who is pushing the buttons, pulling the levers, and producing today, and Gage doing some of that remote tracking. I'm Sawyer Rosenstein. I've been your host for today's launch broadcast. We'll head on out of here with D-Wise's slow motion video, and we will see you all later.
And here we go.
There's the deluge. Here's ignition.
Roger roll, Atlantic. Doubling up.
Did it just do a Kerbal?
Back to the moon and beyond.
Put that in the big bag, Gino.
Back at home, we all have a lot of work to do, but from here, that sure looks like a perfect world.
Propulsion continues to be nominal.
We did have an observation. 343 unfolds to go.
It's orange.
Water towers can fly!
Bingo! Right in the center.
Where's Jacqueline? There it is!
That was surreal.
That's not what we want to see.
No!
Oh my God.
Yikes. You bet. We don't need any more of these.